Hello. In this video, we're going to find the magnitude and direction of a sum of two vectors given the magnitude and direction of the original two vectors. So vector u has a magnitude of square root 10 and a direction of 71.5. V has a magnitude of root 53 and a direction of 254.1 degrees. So what is the magnitude and direction of vector u plus vector v? So let's focus on vector u first. Now I'll draw a rough sketch of this. So vector u has a direction of 75 or 71.5 degrees. So we'll start like from, I guess, the positive half of the x-axis, and then 71 degrees will come up like that. So that's 71.5 degrees. And I'll drop my altitude down to create my right triangle. And I know that the length from the initial point to the ending point here is 10, square root of 10 units. And so then to find, and I'll say that this right here is our vector I going that way, and then this is j going up. And we can say that, for instance, your vector i's length, so that's your cosine of 71.5 would equal I over root 10 based on the Pythagoras or the SOHCAHTOA. So square root of 10 times cosine 71.5 would equal I. And then we'll do the same thing for j when we get there. So j is going to be your sine, so it's going to be the square root of 10 times the sine of 71.5, and that will get us j. Calculating these out, I ends up being 1, while j ends up being 3. And we know that we're going positive to the right and positive up, so the component form for this would be 1, 3. Let's do the same calculations for vector v. And I'll again start by drawing a rough sketch here. And so here's the positive half of the x-axis. This time we're doing a direction of 254 degrees, which puts us down this way. 254.1 degrees. All right, and again, I can, if I just extend this out some here, and then down to make my right angle, once again I'll call this I for my direction left, and then this is j for the down vector, and it's the same setup here. So the I vector is done by cosine, so I will equal square root of 53, because that's your hypotenuse, times the cosine of the 254.1, and j will be the sine value, so root 53 times the sine value of 254.1. And once again, we'll type those into the calculator and we'll come up with some nice values for I and j. I is the negative 2, while j ends up being a negative 7. Notice that we are going left for I and down for j, so they're both negative, so component form will be negative 2, negative 7. All right, I'm going to go to the next page in order to find the magnitude and direction of their sum. Since u is 3, 1 and v is negative 2, negative 7, we can find their sum by simply adding them together. So u plus v will end up being 3 plus negative 2, which is 1, and 1 plus negative 7 is negative 6. We could do this with the parallelogram method as well, remember. So drawing the sketch of this, if we start vector u at 0, 0, we'll go over to 3, 1. So there's vector u. And then vector v will go back 2 and then down 7. So that'll end up down here. And so we'll come down there. And so there's vector v down there. And so then the distance between them is, or the vector from one to the next, is u plus v. All right, now we can find the magnitude and direction of 1, negative 6. The magnitude is simply the square root of the Pythagorean theorem here, so the square root of 1 squared plus negative 6 squared, which ends up being the square root of 37. And then the direction is always the inverse tangent of your y over x, so negative 6 over 1. And that's calculator work. Now our calculator will tell us that the inverse tangent of negative 6 is negative 80.5, but that's not the range in which we look, right? It's supposed to be down here. It's in the fourth quadrant, so it's somewhere between, remember it's supposed to be between 270 and 360. So if I take the negative 80 and add 360 to it, we have a result of 279.5 degrees, and that seems more like it for the direction. Okay, so that's how we find the magnitude and direction. Given magnitude and direction, for now we are done.